I'm going to finish going over Chapter 1, Biology in the 21st Century, by picking up with scientific knowledge. Scientific inquiry involves the sharing of ideas and communication of results to other scientists in the community. A theory is a well-established, highly reliable explanation of a natural or physical phenomenon. Examples are theory of natural selection, theory of relativity, Big Bang theory, and more. Okay, these are large topics in science that a lot of people are doing research projects under. Like the theory of natural selection is technically a part of the theory of evolution. Now, theories are constantly changing with new evidence. Old things that are past dated, like the idea of man evolving directly from apes, that little thing where you see a chimpanzee and then you see caveman and you see a human. Okay, that's thrown out. Okay, see, thrown out. Whew, it's gone. Okay, but we still know that the theory of evolution is happening. Things are constantly changing. But that's just one topic under the theory of evolution and the theory of natural selection. Okay? So theories, well-established, highly reliable explanation of natural or physical phenomenon that can change with new evidence. Laws, on the other hand, show some aspect of the world that says it's expected to behave in a certain situation, mostly unchangeable. Laws are as set in stone in science as you can get. It doesn't mean a law can't change. If there is new evidence, they can change. But most of the time, it's going to be just very small or slight modifications. Examples of laws are like the laws of gravity or the laws of thermodynamics. Okay, let's take gravity. Within a gravitational field, okay, we've seen this in elementary school, what goes up must come down. No matter how many times I throw a baseball into the air, okay, it's going to fall back down to earth. That's just a law. So again, theories constantly in a state of change, but a reliable explanation. Scientific laws, more set in stone. Okay, now on to microscopes. There are two men that you have to know, Anton von Leeuwenhoek and Robert Hooke. People get their names confused all the time. Anton von Leeuwenhoek invented the modern compound microscope. He's just the one who invented the microscope. Now, Robert Hooke, he's the first person to call it a cell. Okay? He described the first basic unit of life by using slices of cork. So, Anton von Leeuwenhoek invented the microscope that we know, and Robert Hooke called them cells. I'm going to take another video to go over the parts of the microscope. Okay, well, the types of microscopes and technology available today, three things you have to know. Light microscopes. These use visible light and a system of lenses to magnify objects. Any type of microscope that you would see in a standard science classroom, this is the type we're talking about. You can look at living things or you can look at things that are mounted on a microscope slide. But all it does is it shines a light up through a diaphragm, through the objective lenses, up through the body, and into the eyepiece that you look at. Now, we do have to find some math or do a little bit of math with a light microscope to find the total magnification. If it ever asks for the total magnification, you multiply the eyepiece times the objective. The eyepiece is always 10. So to find the total magnification, you multiply the objective lens. That could be 4x, 40x, 100, but you multiply that by 10. So if I wanted to find the total magnification of a planaria I'm looking at, and I'm using a 4x objective lens, I'm going to multiply 10 times 4, which would be my total magnification of 40x. Now, if I'm given the total magnification, but I need to figure out which objective lens I was using, I divide by 10. So if I am looking at an onion cell at 400x magnification, I'm going to divide 400 by 10, and that's going to give me 40x. So I'm going to be using the 40x objective lens. Light microscopes again. The only math you need to know: total magnification, multiply by 10. To find the objective lens, divide by 10. Electron microscopes are very rare. Not every place has them. Very large universities do have electron microscopes, and they are not available to just any scientist. Okay, there's long wait lists for this, and you have to have special training. But it uses a beam of electrons to view objects that are too small to be seen with a light microscope. Now, anything that you put into an electron microscope, if it was living to begin with, it is going to be dead when you get it out, because it does use a vacuum chamber. Okay. But the electron microscope lets us view things that we would never normally be able to see, such as individual viruses, where a light microscope will let us see the cell and some of the parts of the cell. We can use an electron microscope to zoom in to look at the cell membrane, the individual phospholipids on a cell membrane. Okay, so that's really, really cool and fascinating. Okay, light microscopes you can find in a classroom. Electron microscopes, very hard to get access to. Now, when we cannot go out into the field, or our experiments are too unsafe, or it can be unethical or impractical, we use computer models. Okay, so computer models can give us large amounts of data from the safety of our own desks.